So today we are looking at relations and functions and talking about some of those things on these notes, all right? So we are going to skip this warm-up, but just looking at this, how would you do this? So I just wanted to talk about it. We're not actually going to do it, but how this process would happen. When they say to generate ordered pairs, if they give you a bunch of different x values, to get out the y values, you would have to plug them in and graph it, solve it. You're exactly correct, all right? So you'd plug it in, you'd solve it, you'd get out your y values, all right? That's what you'd have to do. Another way is you could graph it and then find where they interact at. So there's a couple different ways. That's kind of what we're looking at. So let's jump into what today is all about. Excuse me. So previously we looked at graphs as a way of representing relationships, okay? Relationships can be represented by a set of ordered pairs called a relation, okay? So that's kind of really what you talked about on Friday, right? You watched my video of notes and saw that, okay? You can also show relations in other ways, okay? Besides being a set of coordinates, you can look at it in these different ways. So you could have tables, you could have graphs, or you could have it as a mapping diagram, all right? And these are just different ways to look at a function, all right? So we've seen graphs, right? We've been given graphs. We've had to check if they're linear, if they are functions, things like that earlier in the year, right? We've seen tables and done that a little bit, okay? So it's the same idea here, and those are all things that you've talked about before, but we're going to continue seeing what those are, okay? So here is the first kind of example you could see. It says, showing multiple representatives of a relation. Express the relation, and the relation includes the points 2, 3, 4, 7, and 6, 8 as a table. Well, here's what you do. When you go to represent these, all you've got to do is take those coordinates, and instead of writing them as a coordinate, you're going to write them in a table. So for example here, for the first one, which is 2, 3, what you would do here is you would take your x value and put it in the x slot. So it would be 2, and then the y value that matches up with that would be 3. And what that tells you is when x is 2, y is 3, which is the exact same thing this coordinate is saying. The coordinate 2, 3 is saying, hey, x is 2, y is 3. Now, to show you how they all kind of go together, what do you think 4, 7 would look like? It would have a 4 in the x and a 7 in the y. And then the last one, 6, 8, would become 6 and 8. So essentially what you're doing is you take all of your x's and you put them in the x part of the table. You take all of your y's and you put them in the y. So you have an x column and a y column here. All right? Any questions on that? All this is another way to take points and represent them as a table. Okay? Now, look at this next one. It says express the, we just did this. Is we took all of these and wrote them in there. Now, here is kind of the next deal. Is express the relation as a table, as a graph, and as a mapping diagram. All right, I'm going to skip the graph. Here's why I'm going to skip the graph. Can y'all plot points? Yes. So if you were to express this as a graph, you would literally just go over and plot the points. So where it says 2, 3, you would go 2 to your x, up 3 to your y. Are y'all with me? The one that might be new to you is called a mapping statement or a mapping diagram, okay? And, so we're going to see that one in a second. Now, what we did here is we got to see this written as a table. So that's kind of what we just did on our first example, right? We had 2, 3. We wrote the 2 in the x column, the 3 in the y column. We had 4, 7. We wrote the 4 in the x, the 7 in the y. 6 and 8. We wrote the 6 in the x, the 8 in the y. Everybody okay with that? Let me just check one thing. Now, let's look at this next one. This next one is example 1 continued, but here they have us writing it as a graph. So I told you we were going to skip it. I forgot that I already put it in there. I changed these notes from last year. Okay, but what I did here was I took it and I gave you what the graph was. So to graph the point 2, 3, we went over 2 on our x, up 3 on our y. There's that represented as a graph. 4, 7, you go over 4, up to 7. 6, 8, you go over 6, up to 8. This is another way to do that. And all you've got to do here is plot the ordered pairs. So before, when it was the table, you took your x's and put them in the x column. You put your y's and put them in the y column. To graph it, you just plot the ordered pairs. Now, the one that is different, the one you haven't seen before probably, is a mapping diagram. And this is where you're going to take them, and you can use these little square boxes or you can use ovals. And I'll show you what I mean by the ovals. Is I typically, when I was learning this, I always used ovals like this, okay? But tomato, tomato, same kind of thing here. You take this, and much like the table, you take it and you split them up. You put your x's in one, you put your y's in another. So for example, all the x values that would show up here are 2, 4, and 6. Everybody okay with that? And then the y values that would show up are 3, 7, and 8. Here is how a mapping statement works, or a mapping diagram. You take your x's, put them in one, take your y's, put them in another, and then you draw lines to connect them. So for example, the 2 goes with which number? 3. So you would draw a line to connect 2 to 3. 4 goes with which one? 7. 6 goes with 8. The beauty of this is that you don't have to have them in perfect order. You could draw it and move them around. Does everybody understand that? You could also have something with 2 different things. Like you'll see here in a few, we could have 2 with the same y value. So we could have something like this where you had a number and it branches off like this into 2 different numbers. Y'all with me? Or you could have vice versa. There's some things that can happen there, but that's why a mapping statement's kind of cool. Okay? All right. Now, let's talk about something with a function that you've always kind of heard about, but you've never probably dived too deep into. When you talk about the domain, the domain is the relation, is the set of first coordinates, or, this is big, x values. So when you think about domain, you want to think of x values of ordered pairs. And then vice versa, when you think about the range, you want to think about the second coordinates or the y values, okay? So the biggest thing to think about here, your domain is always going to be your x's. Your range is always going to be your y's. Are y'all with me? All right, now, here is the thing that can happen here, okay? Is you're going to be given different scatter plots, you're going to be given different graphs, you're going to be given tables, mapping statements, and you're going to be asked to give the domain and the range. Are y'all with me? Now, here's how it's going to work. Is you're going to want to write it as inequalities for some of this. You're going to write it as straight points for others. It all depends on what is given to you. Looking at this example, what do you notice? We have what? What is this? A line. Okay, now, the reason this is important, do you see how the line is connected? It is not individual dots. That means your domain and range are going to be inequalities. That means when you write them, you're going to have to use the symbol that it's got to be, hey, it's going to be an and statement where it's between this and this. Are y'all with me? So when we write inequalities like that, I'm going to give you a little thing to help you. If we think about the domain, it was always some number is less than x, which is less than some other number. Now, you can go back and put less than or equal to, greater than or equal to, things like that. Are y'all with me? Okay, so when we look at this, when you deal with domain, you want to deal with just what? X's. So as I look at this graph, what is my X value where this starts at? 1. So I know my starting point is going to be 1. And then since it's a closed dot, I know for the domain it's got to be less than or equal to X. And then X has to be less than or equal to. Now, let me say this again. The reason that I added less than or equal to is because these dots were closed. They are filled in. Now, what is the second X number? 5. So, the domain here is any number between 1 and 5. And how we represent that is we would say X is greater than or equal to 1, and it is less than or equal to 5. All right? So, that helps us get that inequality. Then you've got to do the same thing for your range, but instead of using X's, what are you going to use in the middle? Y. Okay, so I'm starting off with the exact same way, right? Now, when I'm doing this, here's the thing to see. And I'm going to be very generous at the start of this. But typically when you write inequalities, you always want your smaller number on the left, your bigger number on the right. Well, what are the two Y numbers that we're dealing with here? Well, this is the number 3, and then the top would be the number 4. So, which number is smaller, 3 or 4? 3. So when you write your inequality, you want it to be 3 is less than or equal to Y, which is less than or equal to 4. So that means our range is any number between 3 and 4. Are y'all with me? Is anybody lost on any of that? Is anybody lost on where I got the numbers 3 and 4 or 1 and 5 from? Okay, I got that all from this stuff here. And you'll see me typically, like I like to write it kind of like that, where I just kind of say where my thing is to make it a little bit easier so I know my numbers and I don't have to read my graph. Yes, sir?
What do you do with the signs? Like, how do you know?
The sign should always take this form. Okay, now, you're always going to start with just the inequality, and then you'll add the or equal to if it's a filled in dot or something like that. Now, if they are individual dots, then you don't have to do this. You can just list each individual point. But the thing is, since it is a connected line, you don't want to have to list 3.5 and then 3.51, 3.52, 3.53. You know what I'm saying? Like it is all those numbers you would have to enter in there. It's everything. Okay? All right. Well, if y'all are good, let's go to the next example. Here is an example, and they ask you to give the domain and the range of the relation. Okay. What is this? Is this a graph?
No.
Is it a table?
No.
So then it's got to be a mapping diagram. Here's the thing to remember in mapping diagrams. The first stuff is your X. The second is your Y. Now, are these connected lines? Well, okay, so let me rephrase that. Yes, there are lines that connect the X's to the Y's, right? But what I'm asking you, is this on a graph a picture that has 2 points connected by a line? No. So what that means is when you go to list your domain and range, this is a little bit easier because your domain is just going to be the numbers that are the X's. So as I list my domain here, it is simply just the numbers 6, 5, 2, and 1. Now, don't get confused. These are my fancy parentheses brackets that you use when you do sets. I could never draw them, so I just kind of make a 3 and just make it look kind of weird. All right? That's just what I do. All right? Now, you do the same thing for your range, but instead of looking at your X's, you're going to look at your Y's. So what are my Y's? You just listed your domain and range. So even though we like graphs, sometimes it's a little bit easier to use mapping statements or to use a table. Okay, now, here's what I want to show you. Do you see how a mapping statement is kind of cool? Do you see how the numbers 5 and 1 here? This is what I was talking about. Another example, 5 and 1 both go to the number 0. So that means if you were plotting these points, you would have the point 5, 0 and the point 1, 0. That's all it means. It's where the order just can move around a little bit. It's just another way to represent the data that you see. Questions? All right, let's keep going here. Do you think y'all are ready to try one on your own? Yes. Okay, ready, set, I'm going to give you a minute. Go. Okay, so now looking at this, I just gave you that minute to try and figure this out on your own. All right, here are the things that you should notice. Really easy again here because you have a table, so your domain is going to be your x's, which in this case are 1, 4, and 8. Now, your range, what do you notice? Yeah, there's 2 1s. I'm going to be completely honest with you. You don't have to write it twice, but you're not going to lose any points if you did. All right, so to be honest, your range is really just 1 and 4, okay? But if you wrote it out where you listed the 1 twice, it's not wrong. I wouldn't take any points off. It's just more than you had to do, okay? So if you're ever concerned that you might miss a number and you're not sure if it was used or not before, just write it down again. Y'all with me? Okay, so that's another example of just getting your domain range. All right, now, here's the part where we're going to use domain and range to help us figure some stuff out. A function. Okay, we've talked about functions before. A function is a special type of relation where each domain value has exactly one range value. In other words, here's the big thing. In other words, the x values do not repeat. Okay? Now, you've talked about that before, whether it was last year in your math class or even 2 years ago. Okay? But a function is very special. It is where each x value has exactly one y value. All right? So that means your x could not go 2 different places. If that is the case, then you have a function. So we're going to look at some ways to find out. Okay? So right here, it says give the domain and range of the relation and tell whether it is a function or not. So step number 1 is to go through and list out our domain. Well, our domain is going to be all of the x values. Now, here's the thing that should be a red flag to you when you go to list these. You have the same x number show up twice. So as I list these, I've got 3, 5, 4, and then, what do you see again? 3. Now, for me, when I see that, I like to go ahead and underline them because that tells me this is probably not going to be a function. But I'm still going to check it out and see what happens. When I go to look at my range, I want to list it out. So I've got -2, -1, 0, and 1. Okay? Well, as I list these things out, here's the big problem. Here's the problem makers. I've got this point that says 3 goes to -2, and I've got this point that says 3 goes to 1. Is that where I have the same x value go in 2 different directions? Yes, that is. So that means my x value repeats and it goes to a different location. Therefore, I would say this is not a function. And the reason I can say that is I have an x value that repeats. Questions on that? Feeling okay? Easiest way to see it is if your x values repeat, then it's not going to be a function. All right, let's continue on. Let's look at our next example. Okay, now, This one I put in here purposely to try and trick you, to make sure you truly comprehend and you analyze and think about what's going on. So step number one is we need to give our domain and our range. Well, the first one is going to be your x. The second one is going to be your y. So can we list our domain here? -4, -8, 4, and 5. Okay? Were there any repeats there? No. Now, how do you know in a mapping that there are no repeats? You look at your x's and make sure there's not two arrows going from a single number. Y'all with me? Okay, now, let's list our range. What's our range here? 2 and 1. My question to you, is this a function? Yes, this is a function. So the answer here would be yes. No x values repeat. Okay? In other words, what I'm really saying is here is each x has one y output. Okay? Now, why I said I was trying to trick you here and I really wanted you to comprehend this. Do you see how there's multiple things going to the y's? Yeah. That is okay. You just can't have multiple x's that are the same. You can have multiple y's that are the same, but the x's cannot. That's why it's kind of tricky. That's why it's a little bit different. Okay? I was trying to trick you up there. All right? Now, the last example on your notes. Right here, they ask you to give the domain and the range of the function and tell whether the relation is a function. Now, this is one on the graph, correct? Okay, so as I look at my domain are the x values. Here's what you've got to recognize from here. This x value is what number? It's -1, 2, 3, 4, 5. This is -5 out here. What is it over here? 1, 2, and 3. So my domain here is, I know I'm going to have less than or equal to x, which is less than or equal to something, right? Well, what's the smallest number? -5. What's the biggest number? 3. There's my domain. I know that this part's probably the hardest part today, right? Okay, so we're going to get practice with it. I'm not just going to leave you high and dry. All right, then you've got to do the same thing for your y values. Well, what's this lowest point over here? -2. What's this highest point? 1. So again, you're going to end up with -2 is less than or equal to y, which is less than or equal to 1. Those two, once again, are your domain and your range. Now, I'm going to tell you something that I know you've heard before. Okay? When asked if this is a function, how can we figure that out really easily? When you're given a graph, the easiest way to think about it is something called the VLT. Vertical line test. So as I look here, all right, I've got my vertical line. As I go across this, do I ever have something that's got two x values with different y points? Yes. If you look at this, do you see how this crosses it at two unique points? Therefore, you would say this is not a function. Okay? And then you could just say for the same thing. It repeats x values. Okay? All right. Now, what we're going to do here, we've got a few minutes left before lunch. And then you're just going to do this. Again, no homework outside of class. Digital learners at home who are listening to this recording. Nothing outside of class. This week's all about benchmarks, okay? So I want you to prepare for your other benchmarks. I'm going to give you a worksheet. You work on it here in class. Next period, if y'all feel like you need to work on something to prepare for a different benchmark, feel free to do that. You're still responsible for this material, but we're not going to test or quiz on it until after the benchmarks. Ready, set, go.